Let us now solve some problems on Bohr's atomic model. Let me start with something interesting. Let us take one, match the following. Okay. Coming to the first one, in column 1, it is the energy of ground state of helium plus. Coming to B, potential energy of the first orbit of hydrogen atom. Then kinetic energy of second excited state of helium plus. Then the ionization potential of helium plus. In column 2, we have 6.04 electron volts. The second one is minus 27.2 electron volts. The third one is 54.4 electron volts. Then minus 54.4 electron volts. Okay. So this is what they have given. Now let us solve them one by one. Coming to the first one, that is energy of the, total energy of electron in the ground state, first orbit of helium plus. See, because everything except this, it is actually in volt, it's not electron volt. Okay, everything is given in electron volts. So let me just consider this in electron volts. See, I've given this yesterday minus 13.6 into, in fact, it is a z square by n square electron volt. Coming to z square, for helium z is a 2, n square, because it is the first orbit, it is 1 square. So this is z square and this is n square, right? Now simplify this, you will get minus 54.4 electron volts. So for A, it is of course 4. Okay. Now coming to the potential energy of the first orbit of hydrogen atom, or you can say potential energy of electron revolving in the first orbit of hydrogen atom. So this potential energy can be given as, I told you that potential energy is twice that of total energy. So this can be written as minus 27.2 into z square by n square. So z here is 1 square, even n is also 1. So 1 square. So this is minus 27.2 electron volts. Of course, it is very clear. Okay. Then coming to the third one, kinetic energy of it is a second excited state. Second excited state is nothing but third orbit. Ground is nothing but first. When I say first excited state, it is a second orbit. And when you go for second excited state, it is third orbit. So kinetic energy. And remember, kinetic energy is again the same as total energy, but with a positive sign. So let me put a positive charge plus 13.6 into z square 2 square by n square 3 square. Okay, so this comes out to be plus 6.04 electron volt. And the last one, of course, the only option that has potential. Generally, the potentials are expressed in volts. Of course, you can straight away give it, but no, we will solve that. Ionization potential of helium plus. See, ionization potential, or if suppose ionization energy is taken into consideration, we know that it is the same as total energy, but with positive side. Okay, but here it will be like 13.6. Of course, it will be plus because it is the energy that has to be given into z square by n. N will always be 1 because you'll be removing it from the ground state. Whenever I say ionization, that will be from ground state only. So you can just simplify this and you'll get the answer as 54.4 volt. Okay. This is about match the following. So the last one can be given as, yes, this one. This is a basic one to start with. Okay. Then let us go for one more. Yes. Let us take one more matching. This covers some more things. Match the following. In column 1, we have A Bn by Kn is how much? Then coming to B, if a radius of nth orbit is directly proportional to En to the power x, then what is x? Coming to angular momentum of electron, in the lowest orbital, not the orbit, then 1 by Rn, radius of nth orbit, is directly proportional to z to the power y. What is y? This is very interesting. Coming to column 2, P it is a 0, Q it is a -1, R it is -2, and then S it is 1. Okay. Now let us solve things one by one. Here, in fact, this Vn is potential energy, it's not velocity. Kn is given as kinetic energy. Come on. Potential energy of electron in nth orbit by kinetic energy of electron in nth orbit. Yesterday I told you that potential energy is minus kz a square by r by kinetic energy is equal to, of course, plus half k z a square by r. So kz e square by r, kz e square by r get cancelled. So what do you get? This 2 goes into numerator. Then the answer would be -2. Isn't it? Because there is a minus sign. Come on, you just give it. So for A it is -2. Now go for the second one. That is if the radius of nth orbit is directly proportional to energy of electron in nth orbit. Look at this. Energy of electron in nth orbit can be given as, we know that it is minus half kz e square by r, right? Energy of electron in nth orbit is inversely proportional to r in the nth orbit. I mean, radius of nth orbit. Look at this. En is inversely proportional to Rn. Now, if suppose you consider it to be directly proportional, En becomes directly proportional to Rn to the power -1. Now, this same thing can be written as, of course, Rn is directly proportional to En to the power -1. Okay. In fact, you can write this step directly also. Look at this, they are inversely proportional to each other. So from this itself, we can straight away write this. Rn and En are inversely proportional. So to make them directly proportional, then you have to write it this way. Now from this, the value of x can be given as -1. Isn't it? This is your x. Right? So now the answer is for B it is Q. Okay. Now coming to angular momentum of electron in the lowest orbital. We'll take this in the next page. Coming to C. Angular momentum of electron in the lowest orbital. Angular momentum of electron in an orbital. It's not the orbit. Orbital. So let me give you two things. First one, angular momentum in an orbit electron in an orbit can be given as, yes, according to Bohr it is integral multiples of h by 2 pi. Now coming to B, angular momentum of electron in an orbital. Two things are different. So this can be given as root over L into L plus 1, of course, into H by 2 pi. So now let us calculate for the lowest orbital. What is the lowest orbital possible? 1s orbital. So what is the L value for s orbital? We know that it is a 0, right? Now, so this can be written as root over L into L plus 1. Of course, it is understood. Say this is anyway 0. 0 multiplied by something is also 0. That's it. So for C, you know the option is P. Now the last one. They have given this 1 by Rn is directly proportional to z to the power y. What is y? Now come on, let us write the expression for radius of nth orbit. It can be given as n square h square by 4 pi square m k z e square. Derived yesterday. Now the relation between Rn and z is Rn is inversely proportional to z. Okay, but let us write in this format. Just like Rn is inversely proportional to z, we can do one thing. The same thing can be written as 1 by Rn is directly proportional to z, isn't it? Even now also they are. See, here also they are inversely proportional. Even now also they are inversely proportional. So this can be written as a z to the power 1 or simple z. Therefore, what is y here? Y is 1. Okay. So therefore, y is equal to 1. Now coming to this, for D, it is S, right? Yes. Next. Coming to the next one. Okay. Look at this. According to Bohr's theory, the ratio of electrostatic force of attraction acting on electron in third orbit of helium plus ion and second orbit of lithium plus 2 ion is 3/2 to the power x. The value of x is, this is very interesting. Now say they are asking the ratio of electrostatic force of attraction. Yesterday I told you what electrostatic attraction is. You know, electrostatic force of attraction is given as minus kz e square by r square. Yes, this is what I gave. Now let us consider only z and this. Forget about the remaining. Let me say that it is directly proportional to z by r square. Now we know that this r can be written as, r is nothing but n square by z. R is directly proportional to n square by z. So let me write that this can be given as n square by z whole square, because you know that Rn is equal to n square h square by 4 pi square m k z e square. Look at this. Rn is proportional to n square by z, but because there is a square, I've written square. Okay. Now just is z e square. Now say this can be written as, keep z as it is, and how about this? This is n power 4 by z to the power 2. So this can be written as directly proportional to. Now when this goes into numerator, what do you get? Z cube by into the power 4. Okay. Now the electrostatic force attracting, electrostatic force of attraction acting on, see, they have given two different cases. Third orbit of helium plus and second orbit of lithium plus. Let us take the two cases. Come on. Electrostatic force acting on third orbit of helium plus by the electrostatic force acting on second orbit of lithium plus 2. Okay, so this can be written as, come on, in the first case, you have to consider z cube by n power 4, even in the second case also. In the first case, it is clear that z is at 2, right? So this can be written as 2 cube by, what is the n here? 3 to the power 4, right? By, in the second case, what is the z? 3. So this can be written as 3 cube by 2 power 4. Yes. Z cube by n power 4 in both the cases. Right? Now this can be written as, see, when you take the things clearly, this 2 power 4 goes into numerator. What do you get? 2 power 3 into 2 power 4. by 3 power 3 into 3 power 4. So this can be written as 2 power 7 by 3 power 7. Nothing but 2 by 3 to the power 7. Or this can be written as 3 by 2 to the power minus 7. Because they have asked it in terms of 3 by 2 to the power x. Now what is x here? It is clearly visible. So therefore x is equal to minus 7. This way you have to solve things. Check out. Okay. Let us again take one match the following. This is much more interesting. I'm taking match the following so that now we can cover many things in just one problem. List 1, list 2. Okay. Now in list 1, this is for single electron species. And this is, of course, the ratio. Now, coming to P, R21 is to R12. This is very interesting. Look at the way they have given. R, of course, is radius. The first thing that they gave is always N. And the second one that they gave is always a Z. So it's a very interesting question. R1, R21 is to R12. Then coming to Q, V13 is to V31. T12 is to T21. S. K12 is to K21. So here, you know this T is a time period of revolution. Then V, of course, is velocity. Then, of course, K is kinetic energy. Here, this R is radius. Every time it is N, the first one, and the second one is a Z, these two. Coming to list 2. First one is 9:1. Second one is 8:1. Third one is 16:1. Then fourth one is 1:32. Okay. So this is the question. Let us solve them one by one. Okay. Yes. We'll give you things one after the other. Now coming to the first one, that is P. You know, they have given it as R21 is to R12. They have simply given that it is a single electron species. Let us assume it to be hydrogen only because they have not mentioned any other species. So, come on, as I said, the first one is N, the second one is Z. In both the cases, of course, even this also is n and this is z. Check out. You know, radius of nth orbit is directly proportional, or else let me give you the formula. It is equal to 0.529. Yes. So radius of nth orbit can be given as 0.529 into n square by z. Come on, in the first case and in the second case, it is very clear from this that radius is directly proportional to n square and inversely proportional to z. Radius of nth orbit. Okay, in the first case, I mean R21 case by R12 case. Come on. In the first case, n square by z, right? Because the first one is n, second one is z. I've just taken n square by z. In the second case, it is what? 1 square by 2, isn't it? N square by z. So that's it. The answer can be given as this 2 goes into numerator. What it would be? 4 into 2, that is 8. 8 is to 1. Okay. So for P, you know the answer is 2. 8 is to 1. Okay. Then let us go for the velocity thing in a similar way. Coming to Q. See, Q, they have given it as V13 is to V31. Come on. Expression for velocity of electron in nth orbit can be given as 2.188 into 10 power 8 into z by n. Okay. So this is directly proportional to z, inversely proportional to n, right? Let me take it this way. V13 by V31. In the first case, z is a 3 and n is 1. In the second case, z is 1 and n is a 3. So the final answer is 9 is to 1. So for Q, it is 1. In the options, you can check. So Vn is directly proportional to z, inversely proportional to n, right? Now, coming to the time period of revolution, T12 is to T21. We know that time period of revolution in nth orbit is equal to, or straight away let me give it as directly proportional to n cube by z square. So that just it can be substituted. So what is 1, 2? In this case, I mean in the first case it is 1 cube by 2 square. I mean n cube by z square. In the second case it is 2 cube by 1 square. Okay. So this can be given as of course in the numerator it is just 1 because even this also goes into numerator. Then it is 2 square 4 multiplied by 2 cube, nothing but 32. So it is 1 is to 32 and your answer is S. I mean for R it will be 4. Okay. Next. Coming to the last one, that is S. K12 is to K21. Okay. See, kinetic energy, we know that it is directly proportional to Z square by N square, right? The expression for kinetic energy is, you know that it is 2 pi square mk square Z square e to the power 4 by N square H square. So Z square by N square. Now, kinetic energy of electron in case of this, by kinetic energy of electron in case of, it can be written as a Z square by, no, just a second. Z is a 2. So 2 square by N square. In the second case, Z is 1 by 2 square. Okay, check out. Z square by N square. Z square by N square. So this 2 power 2 also goes into numerator. 4 into 4. Nothing but 16. 16 is to 1 is your answer. So for S it is 3. This way we can solve the question. This is very interesting. Okay. We'll go for one more question. Yes. Look at this question. If E naught is the permittivity of vacuum and R is the radius of orbit of hydrogen atom, in which electron is revolving, then velocity of electron can be given by, this is good. Now let us take things in such a way that we get both the E naught, I mean permittivity of a vacuum, and even R, radius of the orbit of hydrogen atom, and of course velocity. If you can remember, I have given that the centripetal force acting between electron and the nucleus is given as equal to centrifugal force. Okay. Coming to centripetal and centrifugal, What do you mean by centripetal force? I gave it as minus kz E square by R square is equal to minus mv square by R. Isn't it? We have derived all the expressions starting with this. Now, come on. Even this R get cancelled. Yes, we have all the things here. Now this K can be just modified as, see this K, as we know, can be given as 1 by 4 pi epsilon naught into Z into E square by R. So that is equal to mv square. Right. So now let us write the expression for v square, because finally they are asking you to write the velocity of electron. So v square can be given as what? 1 by 4 pi epsilon naught into Z into E square by m into R. Correct? Now this is Z is anyway equal to 1 because it is hydrogen atom. Take it as 1. Now the final expression. Let me write the expression for V. Root over E square is E by root for the remaining 4 pi epsilon naught into M and of course R. This E square when taken under root gives E. That's what. This is all. Okay. One more. Take this. See, according to Bohr's model, if the kinetic energy of electron in second orbit of helium plus is X, then what should be the ionization energy? Of the electron revolving in the third orbit of M5 plus ion. Yes. So this is, of course, having two things. Given that the kinetic energy of electron in the second orbit of helium plus is X, and of course asking the ionization energy of the electron revolving in the third orbit of M5 plus. Come on, let us calculate kinetic energy even in the second case also. After that, I mean, after getting kinetic energy in the second case, we will convert that into ionization energy, or from kinetic energy, in fact, we can write the ionization energy. It's of course simple. We know the relation between kinetic energy and total energy. Of course, total energy and ionization energy. Come on, let us take kinetic energy in the first case. Of course, kinetic energy in the second case also. So what is the relation for kinetic energy? Kinetic energy is directly proportional to z square by n square. So in the first case, it is z square by n square. I mean, z1 square by n square. What is that here? In the first case, that is, of course, 2. Even n also is 2. Come on. Z square by n square by. What is the second one? Look at this. M plus 5. M plus 5 is something which is hydrogen-like. I mean, having just one electron. That means it has to be obviously carbon 5 plus, because carbon contains 6 electrons. When one electron is lost, sorry, when 5 electrons are lost, it will be left with 1 electron. And when 5 electrons are lost, it is written as 5 plus. So here in this case, that is equal to 6. Now coming to Z, in the second case, it is a 6 square by n is a 3. Right. Now the kinetic energy in the first case is also given as x. Let us write the kinetic energy in the second case. So this can be written as, of course, you can cancel out the things. These two get cancelled. Then 3 square, of course, goes into numerator. It is 9 by 6 square is 36. So this is nothing but, just a second, 9 by 36. Let me just write one more. This is, of course, x by ke2. So therefore, ke2 can be written as, even this can be cancelled out, right? ke2 can be written as 4x. Yes. So this is the kinetic energy of electron revolving in the third orbit of this m plus 5 ion. I mean the second case. From this, can we write the total energy? I told you very clearly that kinetic energy and total energy have got just one difference. That is, kinetic energy has positive magnitude, whereas total energy has negative magnitude. And from total energy, I think we can go for ionization energy. We know that ionization energy and total energy also have got the same magnitude, but again with a change of sign. Okay, so the final answer, I mean ionization energy in the second case is given as 4x. Okay. Let us take one more question. Right. Look at this. See the wave motion of electron in a Bohr orbit of hydrogen is as shown in a diagram. The potential energy of electron in the given orbit of hydrogen atom now this is what they have given. See, there is an interesting point in this. Considering what a wave is, I told you that a wave is nothing but one crest and one trough. Check out the number of waves that it has. Starting from this, let us suppose. Up to this, it is one wave. And starting from this, up to this, it is the second wave. Starting from this, up to this, it is the third wave. Isn't it? Look at the thing. This is the crest and trough. One crest, one full trough, one full crest. Of course, you can take even up to this also. That way also. So I can tell you that there are 3 waves in this, right? So number of waves can be given as 3. And you know that the number of waves is equal to, number of waves in an orbit is equal to principal quantum number. So here it is referring to the third orbit. So this is most important because the number of waves is 3. You know, the principal quantum number n is equal to 3. Now this is what we'll be using while calculating the potential energy of electron in this particular orbit. Now we know that potential energy of electron can be given as, in the third orbit, it can be given as, you know, it is minus 27.2 because it is double to total energy. In case of total energy, it is minus 13.6, but here it is minus 27.2 into z squared. What is z here? 1 by n square 3 square. So minus 27.2 by 9. Come on. This can be written as 9 3s are, then 2s are. Minus 3.02 electron volts is the potential energy of electron. So here the interesting point is number of waves is equal to principal quantum number. Okay.